Hey everybody, this is Larry, this is me going Q3 of the weekly contest 354, minimum index of a valid split. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So this problem, I think the important part about this problem is just figuring out what it is asking. And I don't mean that in a very, tautology kind of way, like obviously. Figuring out what it's asking is a thing, but basically the core part of the problem, I mean, and this isn't always as obvious maybe, but sometimes you see these things and then you break it down into components where you can solve the components and then in an efficient time, and then efficient enough time anyway, and then see you can do more. The way that I did this one is it's just figuring out, okay, now you have two halves, or doesn't have to be perfect halves. Try to figure out what the count and the dominant thing. I think this one, once you kind of get down to it, you can kind of maybe guess and be correct, but it is still important to note the observations. One is that there's only one dominant number or for the entire array, right? Because, well, that's what they tell you. And also because only one number can be more than half, right? So if you can't break it into two parts, what does that mean? That means that the dominant number of the entire array has to be dominant of at least one of the parts, right? Because of the pigeonhole principle. Is it pigeonhole? Maybe I keep on saying pigeonhole and kind of make that up. But because you could kind of do a proof by contradiction, right? Suppose the majority of the dominant number is not in either of those. Sorry, that's not true. But let me say it. Sorry, that was. It's directionally what I wanted to say, but what I said is there's a little bit thing off. What I mean is that there cannot be another number that is majority of both parts without being the majority of an entire array, right? So you can have another number that's dominant on the left and another number that's dominant on the right, so the majority isn't in either one of those, or the majority isn't the dominant in either one, but they cannot be the same number, because if a number is dominant on the left and dominant on the right, then by definition, that number is going to be dominant over the entire array. Sorry, I think I said that imprecisely and therefore incorrectly. So hopefully that clears that up. So you do need that proof, so that, I mean, I guess you could YOLO it always, but if you have that proof, then you are able to move on and kind of work based on this assumption. And then now you just have to keep track of the majority element and the majority element, and then whether that majority element is both dominating the left and dominating the right. And you can do this in a number of ways. You can do it with basically a sort of, it's not a sliding window per se, but it's kind of like, I forget what it's called, or a sweep line. That's the word I was looking for. A sweep line, right? And kind of maybe prefix sum if you wanted to do it that way. I actually usually do these with prefix sum, not always, but very often, because the penalty for prefix sum versus just like a rolling thing is space, but it's linear space. I'll tell you why this, or I'll show you my code in a second. So here, as I said, I try to find the majority element, and the count, right? But yeah, so then now I do a prefix sum. The prefix sum just, so here, prefix sub I is the number of the majority element to the left of I, not inclusive, so exclusive, right? So not including I, right? So then now we just have to rephrase the original question that they give you, right? So this part is prefix sub I is equal to the number of the majority element to the left of I, and I is equal to the total number of elements to the left of I, right? because if I is equal to 1, you have one number to the left of I, right? And then the second half of, so this is just, showing the majority, and that's fine. And then this part is the second half, the right side, right? So mx minus prefix of I is equal to the number of majority element to the right of I, inclusive of I, and n minus I, of course, is equal to the total number of elements to the right of I, inclusive of I. So then now we just do this really simple math to show that it's strictly majority on both left and the right. And if it's true, then we return I minus 1, and that's it. Yeah. So what I was saying with prefix sum is that you can actually just keep track of this with a variable. You don't really need the extra linear space. And you can actually, so you don't need that linear extra space, so you can actually solve this in linear time and constant space, because you don't need the prefix sum and you do a rolling, sweep line thing. But for me, like for competitive, I'm not worried about linear space in general, so that's why I have it, like this. You may also say that, well, Larry, isn't this linear space in doing it in counter? You could actually use, is it Freud or or more? Someone's voting algorithm. I'm blanking out off my head, but there is a majority algorithm that you can do in linear time and constant space. So if you really want to get it to strictly linear time and constant space, you can use that to get the maximum element and the count, and then follow the rest of the sweep line thing. I'm not gonna do it for you. Practice that at home, and that's all I have for this one. Let me know what you think, and you can watch me solve it live during the contest now. Misread that one. Whoops. Times 2. Okay, so it's like majority. Yeah. Minimum indexed. Okay. How do I do it? So the separate ways don't have to. For example, a number can dominate the left and the right, but the few. No, that's not true because it's by contradiction. So it has to be the max element. Max frequency element, because otherwise by pigeonhole has to dominate one of the halves. Yeah, okay, I think that's fine. Oops. Okay. And then now. Okay, and then if, okay, so nums of I is, oh no, prefix of I. If, so this is the first I plus 1 number. The prefix of I, no. Yes, okay. Though technically it would never happen, but okay. So if this times 2 is greater than I plus 1 and prefix of I times 2 is greater than n minus I for 0, is this true? So if the index is 0, this would be 1, and this would have return I, right, return -1. Get 4 and 6, that's not great. Also, this should not be anyway. And 0, This is this right? 0 is no numbers ahead of it, so no. So the 0 index is 0, numbers ahead of it. Okay, and so this should be more right. Maybe. We split the index at 2, but I think I labeled it as 3. That's why. Okay, let's worry about. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about these problems. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.